Okay, Unit 4. Let's start off with the charging. Okay, charging is one of the easiest lessons we have in all of the syllabus. Okay, charging, we don't talk that much about charging. Honestly, we don't have that many questions regarding charging. But when we talk about an uncharged atom, if we have an uncharged atom, how can we describe this uncharged atom? An uncharged atom. An uncharged atom has the same number of protons as it does electrons. So the protons are equal to the electrons. Let me write it down. The protons, okay? Hmm. Protons are equal to the electrons. If I have a positively charged, okay, if I have a positively charged, then the protons are greater than the electrons. If you have a negatively charged atom, then the electrons are greater than the protons. Okay, so this is how we charged and how we charge an atom, how we charge any material. Okay, we need to increase or decrease the number of electrons. Okay, we increase or decrease the number of electrons. The number of protons is always constant. For charging, the number of protons, we cannot change the number of protons, we can only change the number of electrons. Type. Um, if I have a charged particle, for example, a positively charged particle, then we draw the electric field around it. How do we draw the electric field? The electric field is moving outside, okay, outwards. And if we have a negatively charged particle, then the electric field would be facing inwards. Okay. Then we have a question, what is the electric field? Define what is an electric field. Well, an electric field. What is an electric field? It is a charge around a charge. Sorry, a region around a charge. Hmm. A region around a charge. Around a charge. In which other charges other charges experience an electrostatic force. Electrostatic force. So it's a region around whatever charge, a positively charged or a negative charge. Do I have to draw these lines with a ruler? Preferably, yes. Yes, it's preferably if you do draw these lines with a ruler. Okay, what is an electric field? It's a region around the charge in which other charges experience an electrostatic force. How can I differentiate between a strong electric field and a weak electrical field? If I have a positive charge with very few lines around it. Okay, very few lines, and the distances between these lines are quite large. And if you have another charge with too many lines, okay, if I draw too many lines, for example, if I draw 8 lines or if I draw 16 lines or whatever, the distances between these lines are much smaller, and therefore the force or the strength of the electric field, the strength of this electric field is much stronger. This is a stronger and this is a weaker, okay, a weaker field. Why? Because of the number, okay, because of the number of um, lines, or we can say because of the distances between the lines. When the distances between the lines decreases, then the field becomes stronger. Okay, how can I um, define the direction of the electric field? How can I define the direction? Okay, what's the direction of an electric field? Of an electric field. It is it's outwards from a positive charge and it's inward in a negative charge, but that's not the definition. Definition is it is the direction of a motion. Okay, it's the direction. Okay, the direction of the force, not the motion, the force on a positive charge, inside the field. On a positive charge, huh? Inside the field. What do I mean by the direction of force on a positive charge inside the field? For example, if I have a positively charged um, well, whatever, proton or whatever, in next to another positively charged proton or another positively charged particle. Okay, this is positively charged. In which direction will this proton or will this charge move? It will move outwards with the same direction, okay, of these arrows. What if I have the positive charge in a negative field, in a negative region? It would be attracted inwards. It would be attracted inwards. And that's why we say that the same charges repel and the opposite charges attract. Same charges repel and opposite charges attract. Okay? We can say, we can write it down here, okay, that the same charges repel, okay, repel, and opposite charges, yeah, opposite charges attract. And last but not least, uh, how can I charge how do you say it? How can we charge an insulator? How can we charge an insulator? How to charge? How to charge an insulator. I have an insulator, okay? I have two insulators. We actually need two insulators, such as a dry cloth and a plastic rod, which is the most famous example that we'd have, okay? You have a dry cloth, okay? Let's assume that this is a dry cloth, okay? And another plastic rod. So this is a plastic rod. Initially, both materials are uncharged. They're uncharged. How do I know that they are uncharged? Because they have the same number of protons and the same number of electrons. For example, this has three protons as well, and both of them have three electrons. How can we charge these insulators? By friction. By friction, by rubbing, for example, the dry cloth on the plastic rod or whatever, okay, by friction. So this is a dry cloth and this is a plastic. It has to be a plastic rod. It has to be a plastic rod. It cannot be, for example, a metal rod. Okay, it needs to be an insulator. It cannot be a metal. It cannot be a metal. It has to be an insulator. So plastic rod, a wooden rod, whatever, and a dry cloth. Okay, by friction between these two objects, electrons will start to transfer from one of them to the other. Okay, it doesn't matter from which to which, but for example, let's say that they will transfer from the plastic rod to the dry cloth. Okay, so the electrons will transfer from the plastic rod to the dry cloth, thus making the dry cloth negatively charged. So now the dry cloth is now negatively charged. Why is it negatively charged? Because it gained electrons. Okay, it gained electrons. Where did it gain these electrons from? Okay, from the rod, from the plastic rod, by friction. Okay, and what about the plastic rod? Well, the plastic rod will become positively charged. Why? The plastic rod. Plastic rod. It is now positively charged. Why is it positively charged? Because it lost electrons to where? It lost electrons to the dry cloth. One of them has to be positive and the other has to be negative. Is it a must for the dry cloth to always be negatively charged? No, it's not a must. Okay? It could be positively charged, it could be negatively charged. It depends on the question. Depends on the question. Okay? So this is the only example we have in this lesson, charging, how to make a positively charged object or how to make a negatively charged object using friction. Using friction. Okay? Well, moving on to the more important part of this lesson, which is the circuits. The circuits. Circuits. Okay. We have a lot of components in circuits. We have a lot of components in circuits. But mainly we need to talk about um, series and parallel circuits. We need to talk about series and parallel circuits. Why is that the most important part of this lesson? Because any circuit would be either series or parallel. If you have any circuit, whatever circuit you find, okay, it would either be a series circuit or a parallel circuit. So the difference between a series circuit and a parallel circuit, let me uh, draw it quite quickly. A series circuit, it has to have some sort of power source, which is a battery, a cell, or whatever. Okay, and this cell, it could be connected to several components. Okay, so if it's connected to a switch, for example, this is an open switch. We call this an open switch. Why is this an open switch? Because the current is no, it's not passing through. This is an open switch. Okay, so the current is not passing through, and you have a, let's say, an ammeter which measures the current in the circuit. And then you have, let's say, a fixed resistor. This is a fixed resistor and a lamp. And let's add another variable resistor. So a variable resistor. So all of these components are in series. They are all in series. Fixed resistor, the lamp, and the variable resistor. And then you need to measure the potential difference across each of these components. So to measure the potential difference across each of these components, you kind of need three different uh, um, voltmeters. Okay, a voltmeter for the resistance across the for the voltage across the fixed resistor, and then another one for the lamp, and then another one for the variable resistor. That's if you want to measure the voltage across each of these components. What about the current? What about the current? You only need one ammeter. Why do I only need one ammeter? Because the current is constant. Okay, the current is the same in the whole circuit. It's not constant, it's the same in the whole circuit. Okay, what's the difference? The difference is because I can change the current by changing the resistance. By changing the resistance, the current could change. But it is the same throughout the whole circuit. So if I ask you what is the current in the battery, it's whatever number. It's whatever. What's the current in the variable resistor? It's the same number. In the bulb or in the lamp, it's the same number. Okay. So in whichever position, whatever point in this circuit, the current will always remain the same. Okay. It's always the same. So in series circuit, the current, okay, is the same. What about the voltage? What about the potential difference? What about the voltage? No, the voltage is different. Voltage is different. How is the voltage different? For example, if the voltage of the battery is 24 volts, then this 24 volts will be divided onto these three components. It doesn't necessarily have to be equal. Okay, the voltage doesn't necessarily have to be divided equally. It doesn't have to be 8 volts, 8 volts, and 8 volts. No, it could be, for example, that it took 10 volts, for example, the lamp took only 2 volts, and then the and then the variable resistor took 12 volts. But the total voltage, the total potential difference of these three resistors, of these three components, is what is 24 volts. The total potential difference of these three components is what is 24 volts. Okay? So there's a huge difference. There's a huge difference between saying what happens to the voltage and what happens to the current. The voltage is divided, yes, so it's different for each component, but the current is the same across the whole circuit. The current is the same across the whole circuit. Okay? Type. Good. What about if we move on to a parallel circuit? Let's draw a parallel circuit. Parallel circuits, you'd have the battery connected to another switch, another open switch, and let's say an ammeter, okay? And this battery is connected to
Hi.
the same, okay? This battery is connected to the same resistor. This resistor has an ammeter connected in series with it, okay? And let's say we have a lamp which is connected also to another ammeter, and then the variable resistor also connected to a third emitter. Okay, connected to a third emitter. And then I can add only one voltmeter to this whole circuit. I can add only one voltmeter to this whole circuit. Why can I add only one voltmeter to this whole circuit? Because all of the components, okay, which are in series, I'm talking about these three components which are in series, will have the same voltage. So the difference between a parallel circuit and a series circuit is what? Is that the parallel has the all of the voltage. Let's say that the voltage is the same, but the current is divided. Current is divided. It's different. Again, current doesn't have to be equal in each of these branches. For example, if the total current in this battery, in this circuit was 12 amperes. 12 amperes. What happens, okay, what happens to the current in each of these branches? The current has to be less, okay? Current has to be less. Let's say that the current in this one is 2 amperes, the current in this one is 4 amperes, then the current in this one would be 6 amperes, okay? The current has to be divided. The current has to be less than the total current. But all in all, the total current, if you add up 2 and 4 and 6, the total current would be 12 amperes. Okay? Now, the current in each of these branches depends on what, Shabab? It depends on the resistance of each resistor. Depends on the resistance of each resistor. Meaning that if you have a higher resistance, if you have a larger resistance, what happens to current? The current decreases. If you have a larger resistance, what happens to the current? The current decreases. And if you have a much smaller resistance, what happens to the current? The current increases. Okay, so just by looking at these components, you'd say that the fixed resistor has the highest resistance. The fixed resistor has the highest resistance, while the variable resistor has the least resistance, and that's why it has the highest current. Okay. Um, and each of them has a voltage which is the same as the battery. Let's say if the battery is 24 volts. So if I ask you about the potential difference of any of these components, it would also be 24 volts, and that's why I only used one variable, voltmeter. That's why I only used one voltmeter. But there's a difference between saying what is the potential difference and what is the EMF, or the electromotive force. The electromotive force is the voltage of the power source. You say it's the voltage of the power source. What about the potential difference? It's usually the voltage of the component, of any component. So we have the voltage of some components, and we have the voltage of the power source. So let's define EMF. EMF. It stands for what? It stands for electromotive force. It stands for electromotive force. What is an electromotive force? Electromotive force is the work done. Okay, it is the work done by a unit charge. Work done by a unit charge. By charge, whatever, by a charge, while passing through, okay, while passing through a component, while passing through a component. Electromotive force is the work done by a charge passing through a component. What does this mean? We have charges moving through the circuit. The charges gain energy from where? They gain energy from the battery. They gain energy from the power source. They gain this energy from the source. And then they use up this energy. They use up this energy. Work done by this charge while passing through the component. They use up this energy in this component. For example, the lamp, it uses up this energy to produce light energy. Okay, so it uses up the energy. So it's work done by charge while passing through a component. What is the PD, potential difference? Okay, PD stands for potential difference. Potential difference. What is the potential difference يا شباب? It is the electric work done. Okay, it is the again work done by the source on a charge. Okay, by the source on the charge, or in moving this charge. Okay, in moving a charge around a complete circuit. Okay, around a complete circuit. Okay, around a complete circuit. So this is the difference. Basically, we say that the EMF is the voltage of the battery and the potential difference is the voltage of the device. But if we want to be more specific, then I would say that the electromotive force is the work done by the charge. The potential difference is the work done by the source. Work done by the charge while passing through a component. The other one is the work done by the source in moving the charge around the complete circuit. Moving the charge around the complete circuit. Right. And then we have a very famous equation which is V equals IR. Voltage V equals IR. This is the most famous equation that we will be using um, in almost any circuit questions. V equals IR. Then we have some other equations. One of them is relating the current to the charge. It's relating the current to the charge, which says I equals Q over T. Which says what? I equals Q over T. What is I? It's the current. What is Q? It's the charge. Okay. Sometimes we say that the current is the charge per unit second. The amount of charge, the rate of this charge. Okay. The charge, and this is the time. Amount of charge passing per unit time. And then we have another equation. Another equation. What is this other equation? V equals E over Q. V equals E over Q. What's E and what is Q? E is the amount of energy per unit charge. It's the amount of energy per unit charge. What is V? It's the voltage. It's not necessarily. It's not. I don't. I won't have to say calculate the voltage. I can say calculate the potential difference, or I can say calculate the electromotive force. So the potential difference and the electromotive force and the voltage, they're all the same. How can I calculate them? Either using E over Q, or by using IR. V equals IR, or V equals E over Q. Okay, what is the definition of the potential difference? It's the amount of energy per unit charge. Or the definition of the voltage, it's the amount of energy per unit charge. Okay, amount of energy per unit charge. V equals IR, I equals Q over T, V equals E over Q. And then we have some other equations. What are these other equations? How can I calculate the power? How can we calculate the power? Power equals IV. Power equals IV. And from this equation, I can actually come up with two other equations. From actually more like three other equations. How can I come up with two or three other equations? If I do not have the current, okay, if I don't have the current, from this equation, you can say that the current is I equals V over R. I equals V over R. So from this equation, I can come up with another equation for the power, in which power equals, instead of saying I would say V over R times V. Instead of saying IV, I would say V over R times V, which is basically V squared over R. So power could be equal to V squared over R. Or, or you could say that the power, instead of finding the voltage, okay, if you do not have the voltage, you can say IR. So I times IR, which would be equal to I squared R. I squared R. Do I need Okay, do I need to memorize these equations? No, you do not need to memorize these equations. You actually need to memorize only this equation. And then from this equation and using the first equation, which is V equals IR, you can find the missing current, or you can find the missing voltage and just substitute in the equation finding P equals IV, which would be the easiest way out. Okay, P equals IV. If you go back I don't know how many lessons, okay, when we talked about energy and power. We said that power equals energy over time. Power equals energy over time. And therefore, energy was equal to the power times time. Power times time. Power equals IV, therefore energy equals VIT or IVT. VIT or IVT. So it's the same. And definitely, the time needs to be in seconds. Time must be in seconds. If you are calculating the power in watts and calculating the energy in joules, if you are calculating the power in watts, in watts and the energy in joules. Why? Because we have another way in calculating the power. We do have another way in calculating the power, which is the kilowatt hours. Is it a different way of calculating? It's basically the same. Kilowatt hours is basically the same. But instead of using very small numbers, watts and joules, I will use much larger values. How so? Let me write it down. Kilowatt hours. Watt hours. What is kilowatt hours? Basically, kilowatt hours, and I'm multiplying the kilowatt times hours, which is power times time, so I'm finding the energy. Kilowatt hours is another form of finding energy. But instead of saying, now I need to calculate the energy, which is a couple of billion joules, instead of saying I'm calculating a couple of billion joules, no, I'll only find a couple of thousand kilowatt hours. A couple of thousand kilowatt hours. So how do we find it? Energy equals power times time. Energy equals power times time. Instead of saying that the power has to be in watts, no, the power in this question, in this case, needs or must be in kilowatts. The power must be in kilowatts. What about the time? The time has to be in hours. The time has to be in hours. So if you have the time in seconds, if you have the time in minutes, then you can simply convert the time into hours, okay? If it's in seconds, you'll divide by 60 and divide by 60 again. If it's in minutes, only divide by 60 once. And the power, you need to have it in kilowatts. So if it's in watts, divide by 1000. If it's in megawatts, then you need to multiply it by 1000. Multiplied by 1000, and then you can find the energy. And then finally he will ask you, I need to find the cost. Okay, the cost. How much will I pay by the end of the month? How much will you pay by the end of the month? All you do is find the amount of kilowatt hours used up. All you do is find the amount of kilowatt hours used up. And then all you do is multiply by the cost per kilowatt. The cost per kilo watt. So if he says, for example, 1 kilowatt hour is equal to, let's say, what, $0.5, which is a bit too much. Okay, if we say that this is the cost per kilowatt hour, so if you use up in a month, okay, in 1 month, if you use up 200 kilowatt hours, then all you do is 200 times zero point 0.5, which is a total of $100. Total of $100. That's all you'll have to pay by the end of the month. Okay. That was quite quickly the some of the equations that we will be using um, throughout this lesson. And then some other components. We need to talk about some of the other components that we have. What are some of the other components that we have? For example, we have I said the variable resistor, okay? We have another component which is a bit tricky. Another component which is a bit tricky, which is a sliding contact, okay? A sliding contact. I know a lot of us actually do not like to solve questions with sliding contacts, but they're not that difficult. They're not that difficult. I will draw the sliding contact in two different ways. Two different ways. First of all, I have a battery connected to a very long resistor. Okay, a very long resistor. And then this battery, okay, you have another branch, which is, let's say, connected to a lamp, okay, which is connected to a lamp and a sliding contact. Okay, okay, I'll draw this same circuit, but with a very small tweak. You have the battery and you have the same long resistor. Okay, the tweak is that instead of instead of the branch beginning from the top, that this branch will begin from the bottom. Okay, and then you have the lamp and you have the sliding contact. What's the difference between them? What is the difference between them? As let's write it down. Okay, هنا from A to B. Let's write هنا from X to Y. Okay, from A to B and from X to Y. As you move further away from this conjunction point, can you see this point? Okay, this conjunction, this point. As you move further away from this point, the resistance increases and therefore the potential difference increases, and the brightness of this lamp also increases as you move further away. So in this case, as you're moving further away, as I'm moving further away from A, from this point, as I'm moving further away from A, as I'm moving downwards, in this case, as I'm moving A downwards, as the contact moves from A to B. From A to B. What happens? You'll have to say that the resistance of the lamp increases. Okay, resistance increases. طيب, when the resistance increases, what happens? Voltage also increases, or the potential difference. Potential difference increases of the lamp. And then what happens to the lamp? You can say it becomes brighter. Brightness increases. Brightness increases. Okay. The resistance covered. What do I mean by the resistance covered? At this point, let me. Okay. At this point, it's only covering this part of the resistor. At this point, it's only covering this part of the resistor. As the sliding contact moves downwards, it covers a larger part of this resistor, and therefore the lamp becomes parallel. The lamp becomes parallel to only this part. I mean, if it's at this point, then it's only parallel to this part. طيب, what happens if it moves further downwards? What happens? It becomes parallel to a greater part of the resistor. And if you take a greater part of the resistor, therefore the voltage and the resistance would increase, meaning that the brightness of the lamp would increase. The brightness of the lamp would increase. Okay? What happens to current as the resistance increases? You can say that the current decreases or whatever, but in this question, he will not ask you about the current. This question, he will not ask you about the current. Okay? What about in the other case, in the other lamp? As the lamp moves upwards, as it moves from Y to X in this case, as it moves, as it moves from Y to X. The same happens, okay? The resistance increases, the voltage increases, and the brightness of the lamp increases, okay? Resistance, covered, the resistance which is parallel, okay? The amount or the part from the resistor which the lamp is parallel to, the resistance increases, the voltage increases, and the brightness as well increases. The brightness, okay, increases. Why? Because you're moving away from this conjunction. Can you see this part? Okay, the further away you move from it, the larger or the higher the resistance, the higher the voltage. Okay, so at this point it's only covering this part of the resistor. At this point it's only covering this part. As it moves upwards, the resistance would increase, the voltage would increase. So the voltage of a lamp and the voltage of the lamp and the resistance are directly proportional. The voltage of the lamp and the resistance are directly proportional. As you increase the voltage, the brightness increases. And sometimes we'd say that the temperature increases, and this is, I'll talk about this just in a second. Okay. As why? So this is the sliding contact. This is what we mean by a sliding contact. Potential divider. Sometimes we call it a potential divider. A potential, okay, potential divider. Okay, this is what we call a potential divider. Right. What else? What other components do we have? Very quickly, we can talk about the thermistor. Okay, a thermistor. What is a thermistor? This is a thermistor. It's like a resistor. Okay, with a um, it's like a resistor, but how does this thermistor behave? How does this thermistor behave? Um, as the temperature increases, what happens to resistance? As the temperature increases, the resistance, okay, the resistance decreases. The resistance decreases. As the temperature increases, the resistance increases. They are both inversely proportional. Okay, inversely proportional. How can we draw the graph? Okay, the graph would be somewhat like this. Okay, this is the temperature and this is the resistance in ohms and temperature in degrees Celsius. As the temperature increases, the resistance decreases. Thermistor could be used in fire alarms, for example. Thermistors could be used in fire alarms. It's made of some material which acts against the temperature. As the temperature increases, the resistance increases, which is actually quite opposite, to the normal wire. What do I mean to the normal wire? If you have a normal copper wire, what happens to the temperature? Okay, what happens to the resistance as the temperature increases? What happens to the resistance as the temperature increases? The resistance increases. If you have a normal wire, which is completely different. Okay, it's something completely different other than a thermistor. Okay, thermistor is inversely proportional to the temperature, while a normal wire is directly proportional to the temperature. Normal wire is directly proportional to the temperature. Okay, need to take this point into consideration. This is thermistor. What about a another component which is called an LDR, which is a LDL, light dependent resistor, LDR. Okay, a light dependent resistor. And from its name, it's a resistor that depends on the light. Again, how does it work? Let's draw the LDR first. Okay, it's a resistor with some light rays falling on it. How does it operate? Okay, it operates as the light increases or as the brightness increases, whatever. As brightness okay, as the brightness increases, what happens to the resistance? The resistance also decreases. It's a sensor which depends on the light. Okay, when the light increases, the resistance decreases. Again, if you want to draw a graph, it would somewhat be like this. Okay, the brightness, okay, and the resistance inversely proportional. LDR and thermistor, they're inversely proportional to their surroundings. Okay, again, what else? What other components do we have? We have another very important component, which is a diode. Okay, a diode. How do I draw this diode? Diode is something like this. It's like the play button. Okay, it's like a play button in which it passes the current in only one direction. Okay, current, it allows the current to pass in only allows the current to pass in only one direction. We sometimes call this diode a rectifier. Okay, sometimes we call this diode a rectifier. What do I mean by rectifier? Rectifier means that I'm changing an alternating current to a direct current. Alternating and direct current. What do I mean? What is an alternating current? An alternating current is a current that moves from the positive side to the negative side. This is an alternating AC. This is an AC current. صح? This is an AC. AC. طب what is a DC current? DC current is a current that is only in the positive side. طب does it have to be constant? Does this current in the positive side, does it have to be constant? No, it does not have to be constant. It could increase or decrease or reach zero or whatever, but it cannot move in the opposite direction. Okay? A DC could be increasing, decreasing, it could be somewhat constant, it could reach zero, okay, it could be zero for a while and then it could increase again, okay, but this is what we call a DC, a direct current. How does the diode, okay, act? If we add a diode into an alternating circuit, okay, how do I know that this circuit is an alternating circuit? You'd have a power source which looks somewhat like this. This is the alternating circuit. An alternating power source. A DC power source would either be like this or a battery or a battery. So these are the DC, the direct current sources. How does the diode act in a an alternating circuit? If we add diode, okay, if we add diode next to, let's say, a lamp or a resistor or whatever, it will allow the current to pass in only one direction, in only one which is if and only if the positive side is on this side and the negative side is on this side. Why? Because the current can only pass in this direction. Okay, it can only pass in this direction, so this would allow the current to pass. What happens if the current is switched, which is alternating, huh? As it moves, it will not be allowed. It will not pass through. It will be blocked. It will be zero in the second half of the cycle. It will be zero in the second half of the cycle. So if you want to draw a uh, voltage with time, if you want to see the voltage with the time, or if you want to see the current with the time, what will happen? You'd have half of the cycle on and then half of the cycle off, zero. Okay, half of the cycle on and half of the cycle off, half of the cycle on and half of it off. Okay, so only half. Why? Because you have a diode. You have a diode which allows the current to pass in only one direction. But what happens if I have a battery, okay, and I have a lamp and a diode, but the diode is in this direction, okay? Diode is in this direction. For example, I have the diode and I have the lamp. Will this lamp ever be on? It's always off. Will this lamp ever be on? No, it will always be off. Why? Because the current always moves from the positive end to the negative end. The conventional current passes from the positive end to the negative end. Will it be allowed to pass through the diode? No, it will not be allowed to pass through this diode. It will be stopped. The lamp will not switch on. It will not be turned on. خلاص, it will be off. Why? Because you have the diode in the opposite direction to the current. The diode is now in the opposite direction. Current will not be switched on. Okay, so this is the diode. Sometimes we call it a rectifier. We sometimes call this diode a rectifier. Type. Okay, diode type. What else? What other components do we have? We have some hazards. In circuits, we have some hazards, and then we need to talk about the IV circuits, or sorry, the IV currents. What are the hazards in the circuits? Okay, the hazards, we have two main hazards. Okay, we have two main problems with the circuits. First of all is the overheating. We have overheating, and second of all, we have the electrical shock, electrocuting. Okay, electric shock. It's either overheating or electric shock. How do I deal with either of these hazards? How do you deal with them? First of all, if you want to prevent this circuit from overheating, what do you use? You use a fuse. You use a fuse. What is a fuse? Okay, it is a component that cuts off the current, that switches, it opens the circuit, it breaks the circuit. Okay, it's either a fuse or sometimes we call it a circuit breaker. Okay, a circuit breaker. So we either use a fuse or a circuit breaker. Why? To cut off the current or to break the circuit. To break the circuit. If and only if the current is above a certain value. Okay? If the current exceeds a certain value, So, for example, not certain values, only one value. If I have a fuse which is rated at 10 amperes, if the current increases above 10 amperes, then this fuse will melt. Type, is this a good thing? Yes, it is a good thing. Why? Because it will prevent the circuit from overheating. This is a fuse. Okay, this is how we draw a fuse. Okay, this is how. This is a fuse, a simple fuse with the wire passing through it. Okay, this fuse, it prevents the circuit from overheating, prevents the devices, the circuit, whatever. Okay, the devices from overheating. Okay, by melting. A fuse, it melts. What about the circuit breaker? It doesn't melt. It just switches off the circuit, and then you can open it back again. Okay, then you can close the circuit. You can close the circuit again by pulling back the switch. This is what a fuse does. Okay, prevents the circuit or prevents the devices from overheating. How can I prevent myself from or any other user from an electric shock, from electrocution? By using a ground or an earth wire. By using what يا شباب? By using an earth wire. What is an earth wire? Earth wire, it's usually a simple copper wire. It's a simple copper wire, which is connected to an electric device, usually with a metal surface. Okay, connected to metal surface. Okay, connected, connect. Ah, يلا connected to devices with metal surfaces. With metal surfaces. Why would they be connected to devices with metal surfaces? For example, if you have a dishwashing machine, okay, this is the dishwash. Okay, a dishwash. Dishwasher, it has a metal surface. Okay, a metal surface, and it's connected to the okay, it's connected to the live wire and it's connected to a neutral wire. خلاص, it has it's switched on, it's washing and whatever. If you, for example, touch this dishwasher and it's not earth, you might be electrocuted. Why might you be electrocuted? Because if the live wire, you have the live wire, you have the live wire, okay, live wire, which is the positive end, and then you have the neutral wire, which is the negative end, and then you have the neutral wire. Okay, if the live wire for any reason touches this surface, metals are good conductors of electricity. They will pass these charges on. They have free moving electrons. You will be electrocuted if this live wire touches the metal surface. So how do you prevent yourself from being electrocuted? By adding an earth wire, which is simply a wire connected to the ground. Sometimes we call it a ground wire. Okay, or we say that this device is grounded. We say that this device is grounded. This is an earth wire. What does this earth wire do? If there are any excess, okay, any extra electrons, if you have any extra electrons, okay, if you have an excess of electrons, too many electrons in this dishwasher, in this surface, in this metal surface, what happens to these electrons? They are now able to pass through the earth wire and to the earth, to the ground, okay, preventing you from being electrocuted. Any electrons will pass through this wire to the ground, preventing you from being electrocuted. So any device with a high voltage, high current, or whatever, if this device has a metal surface, then this device must be earthed. This device must be connected to an earth wire. If it's not connected to an earth wire, then there's I don't want to say a huge possibility, but there is a possibility that you might get electrocuted. Okay? If the live wire touches the metal surface. If the live wire touches the metal surface. Okay, this is the earth wire. Okay, and last but not least, I need to talk about the IV graphs. Okay, very quickly. The IV graphs. What are the IV graphs يا شباب? والله we have, for example, if he asks about the resistor, okay, a fixed resistor, a fixed resistor. Sometimes they say it's an ohmic resistor, an ohmic resistor, which is fixed. The resistance is constant. The resistance is constant. So if I want to draw an IV graph, an IV graph in a V slash V and I slash A. How will I draw this graph? It would be a constant slope. constant slope. V and IA. طب what happens if I flip the axes? What happens if you flip the axes? V slash V and I slash A. It will still remain constant. It will still be the same. Why? Because it's constant. It is constant. It's neither increasing or decreasing. How do I know that the resistance is constant? Resistance equals a R equals V over I. R equals V over I. So if at any point on this graph you take a voltage, okay, with the current, you can find the resistance. At another point, if you find the current and the voltage, it will also give you the same resistance. It will give you the same resistance. Why? Because it's a constant slope. So IV graphs, fixed resistor has a constant resistance. A constant resistance us on the slope. Constant resistance. Like what happens if I have a filament lamp? Okay, a filament lamp. Filament lamp. What is a filament lamp, Isha? Filament lamp, uh, the problem with the filament lamp is what? The problem with the light bulb is what? Is that the resistance increases, is that it heats up. And I told you a while ago, as you increase the temperature of a wire, as you increase the temperature of a wire, what happens to the resistance of this wire? It increases. As the temperature increases, let me write it down. As the temperature increases, what happens to the resistance? The resistance increases. Let's draw two graphs, okay? V on the x-axis and I on the y-axis. What will happen, شباب? As the voltage increases, the resistance will also increase. So it will curve towards the voltage axis. It will curve towards the voltage axis. Why? Because this means that the voltage is increasing. The voltage is increasing. And when the voltage increases, the current doesn't increase as much. The current is not increasing as much. Therefore, the total resistance is increasing. Therefore, the total resistance is increasing. Can I flip the axis? Yes, I can flip both axes. I can have the voltage on the y-axis and the current on the x-axis. And thus, in this graph, it will be drawn with an increasing uh, somewhat slope. صح? I don't care about the slope in this case. I care about towards which axis is the graph or is the slope curving. It has to curve towards what? It has to curve towards the voltage axis. It has to curve towards the what, يا Towards the voltage axis. Why does it have to curve towards the voltage axis? Because the resistance is increasing. Because the resistance is increasing, which is very important. So whenever I tell you draw a resistance or an increasing resistance graph, an increasing resistance graph, okay, of anything, it doesn't have to be a filament lamp. If I tell you this, I have a new device which has an increasing resistance, then you have to draw the curve towards, and you have to draw the graph curving towards what? It has to be curving towards the voltage axis. If the voltage axis is on the x-axis, it will have a, let's say, decreasing slope. If the voltage axis is on the y-axis, then you'll have an increasing slope. Okay, this is what this is a filament lamp, an increasing resistance. Okay, an increasing resistance. Okay, increasing resistance. It's very important to understand the difference between a filament lamp and a fixed resistor. Fixed resistor has a constant resistance, while the filament lamp has an increasing resistance type. What if we have, let's say, a diode? Diode, it only passes the current in one direction. So diode, it only passes the current in one direction. So if you have a voltage and current axis, okay, voltage and let's say, let's have the هنا الcurrent, هنا الvoltage. If it's passing through the positive end, okay, positive end, it will allow the current to pass. So if the voltage is on the positive end, the current will be allowed to pass. So it will be kind of a positive. It will kind of be constant resistance. It will have a constant resistance. So what happens if the current is moving in the opposite direction? If the current is moving in the opposite direction, it will not be allowed. Therefore, it would be almost zero. It would be 0. بس that's a diode. It passes when the voltage is positive, but it's 0 when the voltage it's moving in the opposite direction. Okay. Um, what else? Okay, so we have the diode, the filament lamp, the fixed resistors. Okay, so these are the main IV graphs. These are the main IV graphs. Okay. Not too difficult, I guess. I guess we have the problem with circuits. Again, mainly the problem with circuits is that you have too many things, too many components, too many things to think about while talking about a circuit. About a very simple, a very normal circuit, you'd have too many operations to. Yeah, too many calculations, too many devices, too many things to think about in only one question. Okay, I could have one question circuits, paper 4, for example, including all of this. Literally all of these questions, I could have them in only one, let's say, 7 marker or 8 marker question in paper 4. That's the problem with circuits. It's not that difficult, yet it has too many things to think about while solving one question. Okay? Okay. These are the circuits. Type, can we solve? Yes, we can solve in circuits. Let's open up circuits 2. Okay, let's open up the last part of the circuits and start to solve some questions. Okay, let's open up the last part of the circuits and start to solve some questions. Opening up circuits 2. Yeah, page 294. Page 294 in your classified questions, part 2, definitely. Part 2, 294. Hmm, Yeah. Last question in circuits 2. Hmm, Okay, page 294. ماشي. On figure 6.1, sketch the current voltage graph of a filament lamp and explain its shape. A filament lamp. احنا we just said it صح. What is a filament lamp? It has a voltage axis and the current axis, and the graph will bend towards the voltage axis. Okay, it will bend towards the voltage axis in which the voltage is increasing and therefore the resistance is increasing as the temperature increases. Okay, as the temperature increases. Yeah, let's write it down. Should I draw the voltage on the y-axis or on the x-axis? It doesn't matter. Okay, if we have the voltage on the y-axis and the current on the x-axis, then the curve will be towards the voltage axis. It has to curve towards the voltage axis. And then in the explanation, you need to say what? As the voltage increases, or as the temperature increases, as temperature increases, what happens to the voltage or what happens to the resistance? Resistance, resistance increases. Type, when the resistance increases, it curves, or you can say that the slope increases. Okay, slope increases, or you can say that curves. Okay, towards the voltage axis. You can say that the voltage increases. Voltage increases. Okay, this is all because of the increasing temperature. All because of the increasing temperature. Okay, can I find the reading on the voltmeter? Can I find the reading on the voltmeter? I have a battery, okay, and I have another battery. You have two power sources, okay? You have two power sources. ايه ده؟ I have two power sources, 12 and 3. Mister, should I add them up? You should add them up if they're both in the same direction. But you should. Huh? In this case, they're not in the same direction, صح? You shouldn't add them. In this case, they are not in the same direction. You have the positive side of this battery on this side, okay, and the negative side on this side. But the positive of the 3 voltage battery is on the other side, while the negative is on this side. Therefore, we have to minus. In this case, we'll say 12 minus 3, which is 9 volts, okay? This is the total voltage, the total EMF of this is the total EMF of this circuit. Total EMF of this circuit. Why? Because the batteries are in the opposite direction. The batteries are in the opposite direction. حلو. Calculate the current in the 4.2 ohm resistor. 4.2 ohm resistor. This is the 4.2 ohm resistor. Can I find the current? Can I calculate the current? Yes, I equals V over R. I equals V over R, which is 9 over 4.2. يلا. I equals V over R. Why is it 9? Because both resistors are in parallel. Both resistors are in parallel. Therefore, both of them will have the same potential difference. They'll have the same potential difference. So 9 over 4.2, which is 2.1. Yeah, 9 over 4.2, which is 2.1. Again, 2.1 amperes. 2.1 amperes. Determine the current in the 2.1 ohm resistor. طيب حلو 2.1 ohm resistor current I equals V over R. طيب يعني 9 over 2.1 صح? Would that be correct? No, that wouldn't be correct. Why wouldn't that be correct? Why? Because we have a diode. Because we have a diode. In which direction is the current moving? In which direction is the current moving? Is it moving in this direction? Yes, it is moving in this direction. طب Mister, we have the other battery which is moving in the opposite direction. Shouldn't the current be passing through the other direction? No, it shouldn't be passing through the other direction. Why? Because this is the smaller battery. The total voltage, or the, let's say, the resultant EMF, if you might say, the resultant EMF is in which direction? It's in the opposite direction. It's moving towards the left. So the current has to move in this direction. Okay? And through this diode it will pass, but through this diode it will not pass. So the current in this resistor, the current in this resistor is what? Is 0 amperes. The current in this resistor is what? Is 0 amperes. No current will pass. Why? Because of the resistor. 0 amperes. Determine the reading on the ammeter. The reading on the ammeter has to be the same, or if you might say, the summation of the two currents, of the two other currents, which is 2.1 plus 0, which is 2.1 amperes. 2.1 amperes. Okay, this is the total current in this circuit. Total current in this circuit. Calculate the electrical power transferred in the 4.2 ohm resistor. Power equals power equals VI. Power equals VI. So voltage is 9 and the current is 2.1. Power equals V equals power equals VI, which is 9 times 2.1, which is around 18, 19 watts. Okay, 19 watts. This is the total power in this resistor. Okay? Okay, good. Yeah, moving on to the previous question. Moving on to the previous question. Figure 6.1 shows the circuit diagram for a flashlight, a torch. We have the electromotive force of the battery is 4.5 volts. What is this? This is an LED. Okay, probably I forgot to say what's an LED. An LED is a light emitting diode, which is basically a diode which emits light, so it's from its name. It is like a lamp, but it's a bit different. What's the difference? What is the difference between the LED and a lamp? An LED, it switches on, it turns on. So only if the current is passing through this direction. Only if the current is passing in this direction. Now, what happens if the current passes in the other direction? Will it be switched on? No. خلاص, no, it will not switch on. It will not switch on if the current passes in the other direction. So this is an LED, a light emitting diode, which switches on only if the current passes through one direction. Calculate the potential difference across the LED. How can I find the potential difference? Basically, I want to find the voltage. I need to find the voltage. Again, the electromotive force of the battery is 4.5 volts. This is the battery. The circuit contains a 60 ohm fixed resistor, and the current in the LED is 0.02 amperes. So the total current is 0.02 amperes. How can I find the voltage? How can I find the potential difference? V equals IR. V equals IR. طيب احنا we don't have the and I don't have the resistance of the LED. Don't have the resistance of the LED, but you have the resistance of the other one. You have the resistance of the fixed resistor. Can I find the voltage of the fixed resistor? Yes, I can find the voltage of the fixed resistor, which is V equals IR. This is for the fixed resistor. For the fixed resistor, I is 0.02 times the resistance, which is 60. So calculating 0.02 times 0.02 times 60, which is 1.2 volts. Okay, this is not the final answer. Again, this is not the final answer. Why? Because this is the voltage, this is the potential difference of the fixed resistor. The fixed resistor. Can I find the potential difference of this lamp? Yes, they are in series. They are in series, so basically 4.5 minus 1.2 minus 1.2, which is 3.3 volts. Okay, 3.3 volts. Why? Because the voltage 4.5 and I took 1.2, so the remaining voltage will go to the LED. The remaining voltage will go to the LED. Okay. Why the LED does not light up if the battery is reversed? Again, I just said it because the LED only allows the current to pass in one direction. Okay, it allows the current to pass in only one direction. Passing in only one direction. The chemical energy stored in the battery is 1050 joules. Show that the flashlight operates for approximately 3 hours. Show that the flashlight operates for approximately 3 hours. Energy, time, so we have an equation. E equals VIT. E equals VIT. Which is, let's calculate. E equals VIT. I need to find the time. صح, we need to find the time. So basically, time is energy over VI. What is the energy? What's the total energy? 1050. What is V times I? The voltage of the battery, which is 4.5. And the current passing is 0.02. 0.02. So what is the total time? 1050 divided by 4.5. 4.5 times 0.02, which is 11,666.666 seconds. Can I find, can I convert it to hours? Yes, I can convert it to hours divided by 3,600. Yeah, divided by 3,600, this would give you an approximately 3.2 hours, okay, which is almost equal to 3 hours, which is equal to 3 hours. Okay? Calculate the total charge that flows through an LED in 3600 seconds. The total charge. Total charge. I equals Q over T. صح. I equals Q over T. What is Q? The charge. So Q equals IT. Q equals IT. The charge out the current was 0.02 times the time, which is 3600. 0.02 times 3600 is 72. What is the unit of the charge? What's the unit of the charge? Because you keep on forgetting the unit of the charge. It is coulombs. C. Okay, 72 coulombs C. Okay, health. Moving on. This is an interesting question. I like this question. I really like this question. Yeah, let's solve it together. The resistance of P, we have a cylinder which is made of modeling clay. Don't ask how, but this modeling clay is an electrical conductor. It is an electrical conductor. It has free moving electrons, whatever. So this modeling clay has some free moving electrons. The current can't pass through this modeling clay. It has a cross sectional area, a length, and whatever. The cylinder is connected into a circuit. Figure 8.2 shows the circuit, a 9-volt battery. The resistance of P is what? The resistance of P is 4 ohms. The current passing is 1.5 amperes. Current passing is 1.5 amperes. Can you find the magnitude of X of the charge that passes through P in 600 seconds? Can I find the charge? Yes, I just said the equation. I equals Q, Q equals IT. Q equals IT. So the current is 1.5 amperes and the time is 600 seconds. So the total charge passing is 900 coulombs. Total charge passing is 900 coulombs. ماشي, good. The resistance of the cylinder. Can I find the resistance of this modeling clay? I guess so. I guess so. Why? Because we have the total voltage. We have the total voltage and we have the total current. Can I find the total resistance? Yes, I can find the total resistance. R equals V over I. V over the total voltage is what? Is 9 volts. The total current is 1.5 amperes. So the total resistance would be total resistance would be 6. Total resistance would be 6 ohms. 6 ohms. Can I find the resistance of this modeling clay? Yes, I can find the resistance of this modeling clay minus the resistance of the fixed resistor. Don't forget about the fixed resistor. So 6 minus 4 is 2 ohms. This is the resistance of the modeling clay now, at this instance. The cylinder is now removed from the circuit and it's replaced with a new cylinder made from the same modeling clay. The new cylinder is twice the length and half the cross-sectional area. Twice the length and half the cross-sectional area. Calculate the time it now takes for the charge to move through resistor P. Okay. What happens when you increase the length? Twice the length. Twice the length. And I'm increasing the length. What happens to the resistance? The resistance is also increased. They're directly proportional. When you multiply the resistance, when you multiply the length by 2, so the resistance is also multiplied by 2. So the resistance is also multiplied by 2. What happens if you halve the cross-section area? If you divide the area is now divided by 2. The area is now divided by 2. What happens to the resistance? The resistance is also multiplied by 2. Why? Because they are inversely proportional. So this one is directly proportional, while the area is inversely proportional. So basically, the initial resistance was 2 ohms. What happened when you increased the resistance? When you multiplied the resistance by 2, so the total resistance was multiplied by 2. What happens to the resistance when you divide the area by 2? The total resistance was also multiplied by 2. So now the new resistance of this modeling cylinder, of this measuring whatever of this cylinder is 8 ohms. The new resistance is what? Is 8 ohms. طيب حلو. What should I do? How can I find the time? How can I find the time? Well, if you have the total resistance 8 ohms. يا مستر أنا دلوقتي I have no idea what to do. I have no idea what to do. If the total resistance is now 8 ohms, can I find the new current? Oh, I can find the new current. Why? Because I equals V over R. I equals V over R. This is the resistance of the cylinder. This is the resistance of the cylinder. It is 8 ohms. Can I find the total resistance? Yes, I can find the total resistance, which is 8 plus 4. Do not forget about the fixed resistor. The total resistance is now 12 ohms. Total resistance is now 12 ohms. Can I find the new current? Yes, I equals V over R. V over R, in which the voltage was 9 volts over the total resistance, which is 12. So the new current is 0.75 amperes. Can I find the time? If I have current and you have the do not forget about the charge. You have the charge, you have the current, and you have the charge. Can you find the time? Yes, the time would be equal to Q over I. Current would be equal to Q over I. So basically, the time would be equal to Q over I, which is 900 over 0.75 over 0.75, giving you a total time of 1200 seconds. A total time of 1200 seconds. Okay, so this is the total time, or the new time taken for the charge to pass through the cylinder and through the resistor. Okay, ماشي. Moving on to next question. Moving on, to the previous question, I mean. Let's solve this question. I guess this is an easy question. Figure 8.1 shows an electrical circuit. The light intensity of the circuit increases from dark to bright. The light increases. So the light increases. This is an LDR. Isn't this an LDR? Component Y. Component Y is an LDR. So as the brightness increases, what happens to the resistance? Resistance decreases. What happens to the voltage? What happens to the potential difference? The potential difference also decreases. Again, what happens to the he's saying that the resistance, okay, the light intensity increases, okay, too bright. It's now becoming brighter. So as the brightness increases, what happens to the resistance? It decreases. What happens to the voltage? It also decreases. So state the effect of the resistance on component Y. Resistance decreases. Yeah, resistance decreases. State and explain any effect on the reading of the voltmeter. The reading on the voltmeter will also decrease. It will also decrease. Why? Because the voltage is directly proportional to the resistance. الفولtage decreases. Reading decreases. Why does the reading decrease? Voltage decreases. Why? Because it's directly proportional to the resistance. Directly proportional to the resistance. Okay. Um. Okay. Yeah. Moving on. The circuit shown is switched on for 2 minutes. ماشي. The current in the 4 ohm resistor is 3 amperes. 4 ohm resistor is 3 amperes, which is quite obvious because I equals V over R, so 12 over 4 is 3 amperes. ماشي. The magnitude on the charge on one electron is 1.6 times 10 to the negative 19 coulombs. 1, okay, if we write down 1 electron, okay, is equal to 1.6 times 10 to the negative 19 coulombs. Okay, it's switched on for 2 minutes. Switched on for 2 minutes. Calculate the number of electrons that pass through. Each seconds. Pass through each second, each 1 second. Can I find the uh, charge? Can I find the charge in each second? Can I find the charge in each second? Yes, I equals Q over T. I equals Q over T, so Q equals IT. Basically, if we're talking about 1 second, so Q equals the current, which is 3 times 1, يعني 3 coulombs. 3 coulombs. صح? 3 coulombs. This is the amount of charge. This is the amount of charge that passes each second. He's not asking about the total time. He's not asking about the total time. Now, in this question, he's asking about each second. So the amount of charge is what? Is 3 coulombs. Okay. Can I find the number of electrons? Yes, directly proportion. How do you mean with direct proportion? If one electron is 1.6 times 10 to the negative 19 coulombs, what is the number of electrons if I have 3 coulombs? Cross multiply. Cross multiply. So basically 3 times 1 divided by 1.6 times 10 to the negative 19. 1.6 times 10 to the negative 19, which would give you around 1.9 1.9 times 10 to the power of 19 electrons. Okay, it's a simple cross multiplication. It's a simple cross multiplication. Most of your errors would be in that you actually found the total, that you actually found the total charge passing in 2 minutes. And he's not asking about the charge in 2 minutes. He is asking about the charge in only 1 second, in each second. So basically, Q equals IT. T is 1 second, so the charge would be equal to the current. 3 coulombs, and then all I did was cross multiply. 3 times 1 divided by 1.6 would be 1.9 times 10 to the power of 19 electrons. Okay. Okay, yeah. Calculate the power dissipated by the resistor. How can I find the power? Power equals VI. So power equals VI, in which the voltage is 12 volts and the current is 3 amperes. So power equals IV or VI, which is 3 times 12, 36 watts. 36 watts. Quite easy. 36 watts. Huh. Any problems up to now? Um, يلا moving on. يلا previous question. Figure 9.1. Figure 9.1 shows the current potential difference graphs for a resistor, thermistor, and a filament lamp. This is a really nice graph actually. Okay, you have a current, the current voltage or the current potential difference graph for the filament lamp, the resistor, and the thermistor, which quite clearly shows that the filament lamp has an increasing voltage, the resistor has a constant voltage. I'm talking about resistance, I'm sorry, an increasing resistance. Resistor has a constant resistor, and the thermistor has a decreasing resistance. Okay, decreasing resistance. Draw the circuit diagram for this circuit. The resistor, thermistor, and filament lamp are all connected in series with a power supply. They're all connected in series, so this is quite easy. You have a power supply with a fixed resistor, a thermistor, okay, and a lamp. Do they all have to be in this same order? No, they don't need to be in this order. Not at all. Okay? Not at all. Okay. Um, okay. Add a voltmeter to the circuit diagram, okay, in a correct position to measure the potential difference across the resistor. Only across the resistor. Across the resistor would be somewhat like this. This is the voltmeter to measure the voltage across the resistor. Using the graph 9.1, determine the potential difference across the terminals of the power supply when the potential difference across the resistor is 6 volts. When the potential difference across the resistor is 6 volts. So we have this resistor and now it is 6 volts. I want to find the potential difference across across the power supply, which is basically the EMF of this battery or the EMF of this whole circuit. If the okay, if the voltage is 6 volts on this fixed resistor, okay, on the fixed resistor, it's 6 volts. So from the graph, I need to go up, okay, 6 volts, okay, from the graph, it should have a current of 0.4 amperes. It should have a current of what? Of 0.4 amperes. Why? Because I drew a line, okay, from 6, it has a current of what? Of 4 amperes. Does this mean that all of the components would have the same resistance? Would they all have the same would they all have the same voltage of 6 volts, so the total voltage is let's say 18 volts? Maybe. Okay, or maybe not. Okay, it's not necessarily that 6 times 3 would be 18. No, I know that the final answer, okay, I know that some of you have checked the marking scheme and say, well, it's 6 times 3, which is 18 volts, so this is the final answer. No, this is actually the wrong approach. This is the wrong approach for this question. In this question, they are all in series. And you have a current of 0.4 amperes. you have a current of 0.4 amperes. So from this graph, you need to check out the current when it was 0.4 amperes, okay? At this point and then at this point. Can you see these 2 points? You need to check the current at this point and at this point. The filament lamp would have a voltage of 3 volts, and the thermistor would have a voltage of what? Of 9 volts. Of 9 volts. So actually, the total voltage of them is what? Is 3 and 6 and 9. 3 and 6 and 9. So if we add up all of these voltages, 3 plus 6 plus 9, it would give you a total potential difference of 18 volts. Not because you said 3 times 6, which is 18. No, that would be the incorrect approach. Okay, that would be incorrect. Okay, describe a practical use for a thermistor. Thermistor could be used in a fire alarm. In a fire alarm. Okay, fire alarm. This is the most practical use for any thermistor. Okay. Need to find some more difficult questions. I guess this is a bit more difficult. It's not that difficult, but let's solve it. Okay, 285. No, it's just a bit more difficult. 285. Yeah. What is meant by a current? It is the rate of flow of charges. Okay, it is the rate of flow of charges. Rate of flow of charges. Because I equals Q over T, charges per unit time. Okay, charges per unit time. The current in the LDR is I1. Current in the LDR is I1. This is I1. And the current in the 800 ohm resistor is I2. The 800 ohm resistor is I2. Can I find the current in the 450 ohm resistor? Yes, I can find the current in the 450 ohm resistor. Why? Because the total current, which is the 800 ohm resistor, the total current at this conjunction, it splits. It splits into I1 and the current in the 450 ohm resistor. So to find the current in this resistor, you need to simply say I2 minus I1. I2 minus I1. That's it. Because the current is split. It doesn't have to be split equally, but it is split. Can you find the power dissipated in the 800 ohm resistor? Can I find the power dissipated in the 8 ohm resistor? How can I do that? Power equals VI. Do I have the current? Do I have I2? No, not yet. What should I do? What should you do? والله يا مستر, to find this question, it might be a bit more difficult. Okay, it might be a bit more difficult. Um, he said that the current in the 450 ohm resistor is 0.12 amperes. And this resistor is 0.12 amperes. Can I find the voltage? Can I find the potential difference in this resistor? Yes, you can find the potential difference. So V equals IR, which is 450 times 0.012. 0.012 times 450. Yeah, 450 times 0.012 is 5.4 volts. 5.4 volts. This is the voltage of what? This is the voltage of the 540 ohm resistor. 5.4 volts. Can I find the voltage of the other component? Can I find the voltage of the 800 ohm resistor? Yes, simply 9 minus 5.4. 9 minus 5.4 is 3.6 volts. 3.6 volts. So to find the power, we'd say power equals VI. So 3.6 times the current. طب يا مستر احنا we don't have the current. How can I find the current? This is the voltage. Can I find the current? Yes, you can find the current by saying an I equals V over R. I equals V over R. 3.6 over the resistance, which is 800 ohms. 3.6 over 800, which is around it is 0.00 0.045 0.0045 0045. Okay, so this is the current in the 800 ohm resistor. Basically, the power equals VI, which is 3.6 times 0.0045, which is a very small number. Okay, 1.6 times 10 to the negative 2. 1.6 times 10 to the negative 2 watts. Okay, and this is the power. It's a rather hectic question. Okay, too many steps, but again, it's okay. Okay, too many steps, but it's not that bad. 1.2 times 10 to the negative 2 watts. This is the power in the 800 ohm resistor. The brightness of the light that is incident on the LDR increases. Brightness increases. State what happens to the potential difference across the 450 ohm resistor. The brightness increases. The brightness increases. Where is the LDR? هنا when the brightness increases. What happens to the voltage? What happens to the voltage? Voltage, what happens basically to the resistance? Well, the resistance decreases. Then when the resistance decreases, what happens to the voltage? Voltage decreases. What happens to the current? We can say the current increases. He's asking about what again? He's asking about explain what happens to the potential difference across the 450 ohm resistor. If the voltage on the LDR decreases, if the voltage on the LDR decreases, what happens? Okay, if the voltage here decreases, what happens to the voltage on the 800 ohm resistor? It would increase. It would increase. That's it. That's all you need to say. So as brightness increases, okay, the resistance of the LDR decreases. Therefore, the voltage, you can say it also a decreases. But the potential difference or the voltage of the 800 ohm resistor increases. You need to say that the voltage on the 800 ohm resistor increases. Why? Because they are um, um, kind of a in series. Okay, so the resistance of the LDR decreases, so the resistance of the pair the okay, the resistance of the LDR and the 400 ohm resistor decreases, therefore the voltage increases. Okay. Okay. He's not asking about the 800. He's asking about the 450 ohm resistor. So the voltage on the 450 ohm resistor actually decreases. Okay, voltage across it decreases. Why? Because they are parallel. Because they are parallel. In the 450 ohm resistor. He's not asking about the 800 ohm resistor. Okay. Okay.